So let's go back to the lesson. The reason we made estimates when we were multiplying with whole numbers or dividing with whole numbers was to check to make sure our answer made sense. If our answer is not reasonable, then that should tell us we need to go back and make sure that we didn't make a mistake somewhere. A reason that we are multiplying and dividing with decimals, or I should say making estimates when we're multiplying and dividing decimals, is so we can figure out where the decimal point needs to go. So we are going to practice on Math Journal page 217 together using our knowledge from Unit 4 when we were rounding decimal numbers and using our knowledge from Unit 2 when we first started making estimates with multiplication and division. And if you remember, you wanted to make them using our extended multiplication and division facts. So we want our estimates to be something that you can quickly do in your head. So when we go to make estimates and we look at what numbers we should round to, remember, you want to make sure it is a number you can quickly calculate in your head. So let's take a look at the directions. The digits provided in the answer column are correct, but they are missing a decimal point. For each problem, write a number sentence to estimate the product or quotient. Use your estimate to place a decimal point in the digits provided. An example is done for you. So let's look at the example. I have 12 and 2/10 times 1 and 9/10. So they took 12 and 2/10 and they rounded it to 10. That 2 has the 1 stay a 1, so it's just 10. They took 1 and 9/10 and they rounded it to 2. That 9 tells the 1 to go to a 2. So then you have 10 times 2 equals 20. So you know your answer is going to be somewhere near 20. So when you go to put your decimal in, you need your answer to be in the tens place. So we have tens, ones, decimal. Because remember, your decimal is always after your ones place. So let's take a look at 1. 17 and 4/10. So remember, I said earlier, we want it to be something you can do in your head. Could you look at the 7 and look behind it and see it's a 4, so it could stay a 7 and just be 17? Absolutely. But multiplying with 17 is probably not as easy as multiplying with 20. That 7 tells the 1 to go up to 2, so I can round 17 and 4/10 to just 20. I guess it doesn't need to be that large. Times 97 and 5/10. Well, again, I can make 97 and 5/10 go to 98, but I don't think you can multiply with 98 very easy using mental math. So let's look. The 7 tells the 9 to go up to a 10. So 97 and 5/10 actually becomes 100. So now I have a basic extended multiplication fact. 2 times 1 is 2, and then I have 1, 2, 3 zeros to add on. So that means my answer is going to be somewhere near 2,000. So now we have to figure out where the decimal goes. Well, if I put the decimal here, that is only 1 and 6,965 10,000ths. If I put the decimal here, that is only 16 and 965 thousandths, not close to 2,000 yet. If I put the decimal here, that's only 169 and 65 hundredths. If I put the decimal here, it is 1,696 and 5/10. Is that close to 2,000? 1,696 and 5/10. Right, that's close to 2,000. So we are going to put the decimal in between our 6 and 5. So essentially what we are doing, we see that this number is in our thousands place. So that means we need to have our whole number over here in the thousands place. So we can think thousands, hundreds, tens, ones. We know the decimal always goes after the ones. Let's try another one. Number 2. If you'd like to try one on your own, you can always pause the video, complete the problem, and then play the video to see if you got it right. Remember, these are estimates, so your estimate may be a little bit different than mine, but as long as you place the decimal in the right place, you are fine. So if I look at this number, 83 and 1200ths, we would want to round it to our nearest tens, so that way we have the basic multiplication fact. So in the 10 spots, an 8, look behind it, it's a 3, that's going to turn into 80. Ooh, pardon my writing, I'm using the mouse. Times 7 and 2500ths. Well, this one, like I just said, we could have different estimates. This one, I could see doing either way. Could we just leave it as 7? Absolutely. That 2 says 7 can stay a 7 and we're done. Or, I'm going to put another one down here. We could say, well, 7's pretty close to 10 and make it a 10. Let's see what happens. So this is what I was just saying, how our estimates may be a little bit different. 8 times 7 is our basic fact of 56. Add 1 0, because there's a 0 here and none there. 8 times 1 is our basic fact of 8. Add 2 zeros, because there's 1 0 in this factor and 1 0 in this factor. So both of our estimates end up in the hundreds place. So our answer is going to be between 560 and 800. So let's go place our decimal. We know it needs to be in the hundreds place. So our 6 needs to be in the hundreds place. Then we have tens, ones, decimal. Decimal is always after your ones place. And we're going backwards. I know you're used to going from right to left, but we're going backwards to place our decimal. We're going left to right because we're starting. If this ends in the hundreds, then we're saying this has to be the hundreds. And then we're counting backwards to places. Tens, ones, decimal. Let's check out number 3. Number 3 is a little bit tricky. So 36 hundredths. Well, you can think of 36 hundredths as a fractional amount, right? I can think of it as 36 over 100, which is also pretty close to 1/2. Doesn't that 6 tell the 3 to go to a 4? Multiplying with 4/10 might be a little bit difficult. 4/10 is pretty close to a half, so we could call 36 hundredths just a half. That's okay, because we know how to multiply by a fraction. Times 325 and 5/10. Well, let's go to the largest number here, the 300. The 2 tells the 3 to stay a 3. So it's just going to be 300. Well, what's half of 300? It's what half times 300 means. Half of 300. Great. 150. So again, it says that my answer is going to be somewhere near 150. So I know that I need to be in my hundreds place. So again, we're going from left to right. Hundreds, that's where we have to start. Hundreds, then tens, then ones. And always after the one, there's the decimal. And then go back and check it. I have 117 and 1800ths. Is that close to 150? Absolutely. If it was not, then that should tell you, uh-oh, I need to go back and check my work. Make sure I place the decimal right. Make sure I multiplied correctly. Number 4. If we look at number 4, 4 and 8500ths, what is that going to turn into? Right, 5. Times, and this one again, you could have 2 different options, but 6/10. We could make it go to a half because it's pretty close to a half. 5/10 is half. Or we could just say it's close to 1. Because if we round it up, that 6 would make the 0 go up to 1. And then that makes it a super easy fact. 5 times 1 is 5. So we're in our 1 spot. So when we go to place a decimal, we're starting left to right, ones, decimal, because the decimal is always after your ones. 2 and 9100ths, is that close to 5? Absolutely is, so you are correct. Go ahead and pause the video and try number 5 on your own. I will work on it right now, so when you are unpaused, you will see the answer. Tens, ones, oops, sorry guys. So 49 and 1400ths, is that close to 60? Yep, it definitely is. So how'd you feel with the multiplying? Pretty good? Because now we are going to look at quotients. We're going to be dividing. So if you need to take a break, you may. Just make sure you come back so we can finish 6 through 10 with division. Because dividing makes it a little bit trickier. Let's look at number 6. So if we look at number 6, we have 95 and 7600ths divided by 7 and 6/10. So 95 and 7600ths. 9 is our largest, 9/10, so 90. The 5 would make that go to 100. 100 is pretty close to 95 and 7600ths. But now I am dividing. So this is where we have to kind of really think that 7 and 6/10, what's close to 7 and 6/10 but can divide 100 evenly? Because remember, when we make division estimates, we do not want a remainder. We want it to be a whole number answer. So 7 6/10 could go to 10, right? The 6 would make the 7 go to an 8, which is pretty close to 10. And I know that 10 divides 100 evenly, so this would be a good fact to use for estimating. So 1 divided by 1 is our fact, and that's just 1. And remember, when it comes to estimating, we're not adding the zeros on, we're actually canceling. So there's 1 0 in my divisor. That means it cancels out 1 0 in my dividend. So I have 1 0 left to add to my quotient. So my answer is going to be somewhere near 10. So if I go over here, I have tens. We're still going from left to right, adding our decimal in. So since I'm in my tens place, I go tens, ones, decimal. Decimal's always after your ones. Then check it. 12 and 6/10. Is that close to 10? Absolutely it is. So we're correct. Number 7. Number 7, 515 divided by, 515 and 87 hundredths divided by 65 and 3/10. So this one is definitely probably the trickiest one on the page. So 515 and 87 hundredths, what could that go to? Could it go to 500? Let's go ahead and make that 500. And then I have 65 and 3/10. Well, what is 65 and 3/10 semi-close to that divides 500 evenly? So remember, when we're dividing and we're making estimates, sometimes our rounding rules kind of go out the door. So this is pretty close to 50. And you should recognize that 50 can divide 500 evenly. So let's make it 50. Well, 5 divided by 5 is 1. And remember, with division, it cancels zeros out. So 1 0 that's in our divisor is going to cancel out 1 0 in our dividend, which leaves us 1 0 left to be put in our quotient. So here's another tricky part. Other than them being kind of crazy numbers, it says my answer should be in the tens. Should be close to 10. Well, if I follow that, Zoe, it would make it tens, ones, decimal. Because I said the one always goes after, or the decimal always goes after the ones. Zoe, stop. She wants to learn some math with us. But is 79 close to 10? No, it's not. So let's check that again. I don't think we put the decimal in the right spot. What if I put the decimal here, in between the 7 and 9? Even though it's saying my estimate is in the tens, 7 and 9/10, is that close to 10? Right, 7 and 9/10 is close to 10. So even though I was showing you that this says it's in the tens, ones, decimal, this says it's in the 20s, tens, ones, decimal, it is always suggested that you go back and make sure it makes sense. 7 and 9/10 is close to 10. 12 and 6/10 is close to 10. So go back and make sure that where you place your decimal makes sense. That was a tricky one. Oh, number 8 is tricky too. Man, I'm sure you guys have it though. 2 and 76 hundredths divided by 3 and 68 hundredths. Well, let's take a look here. 2 and 76 hundredths, that's pretty close to 3. And 3 and 68 hundredths is pretty close to 4. Uh-oh. How is this number sentence different than our others? Right, our dividend is smaller than our divisor. And remember, when that happens, I could technically write the same number sentence like this. This is still saying 3 divided by 4. Oh, wait, but doesn't that look like a fraction bar? So what this is really saying is if I have 3 and I have to split them into fours, that means I'm going to have 3/4. Well, think of quarters. 3/4, because 4 quarters make $1. If you have 3 quarters, how much money do you have? Right, 75 cents. So our decimal should make 75 hundredths. 9 and 10. So I would pause the video to do 9, unpause it to check your answer, then pause it again to do 10, uncheck it to check your answer. Go ahead and see what you can do on your own. $127 and 25 hundredths is close to 100, so that is correct. This one's tricky. Basic fact. 1 0 in my divisor cancels out 1 0 in my dividend. So 64 is close to 70, so that would be correct. How do you feel about division? I think division estimates are definitely tricky. So last problem, guys. Try this, and I am going to have you go ahead and try it. I'll read it aloud though. 4 families held a garage sale and split the proceeds evenly. They made a total of $1,256.60 at the garage sale. Select the number model that represents the correct amount of money each family earned. So as you can see, they, in all 4 options, gave you the same number sentence. $1,256.60 split with 4 people. So we cannot eliminate any of them based on their number sentence because they're all the same. We have to figure out which one has the correct answer. Now, when I'm looking at this, I see 2 of them that make little to no sense right away before I even try to figure it out. C, if you're dividing a large dividend by a smaller number, so 4, are you going to be making more than what you started with? Is that possible? So you only had $1,256.60 and you split it with 4 people. How is everyone going to get $3,000 all of a sudden? Don't think that one makes much sense. So I am going to get rid of that as an option. Then if I look at D also, if I have $1,256.60 and I split it with 4 people, is everyone only going to get $3.14? I mean, I know 3 times 4 is $12. I made a lot more than $12. So that one doesn't make sense. So let's look at A and B. Which one is correct? Did each person get $31.41 or did each person get $314.15? And then 12 says use your estimate to think about how you solved 11. So let's make an estimate. What is $1,256.60 close to? Go ahead and write that down. Now, what would you change or keep for your divisor? What's your number sentence look like? I'm thinking that I would make it $1,200 and then I would keep my divisor at 4. That would be my estimate because I know 12 divided by 4 is 3. And then I have no zeros to cancel in my divisor to my dividend, so then I have to add 2 to my quotient. So then that tells me that they should be getting all about $300. So which one's correct? Right, B.